In a quiet room in Queensland, Australia, time flows differently. There is no ticking clock to mark the hours, no machines whirring in urgency. There is only a bell jar, a funnel, and something black and thick and silent, something that has not yet fallen. This is the pitch drop experiment, and it has been running since 1927. It was not designed for spectacle. There is no flash of light, no eruption, no dramatic result. Instead, there is waiting, waiting for something to move. Something that looks like a rock, but is in fact a liquid. Pitch, also known as tar, flows, but so slowly that a single drop may take years, even decades, to fall. Imagine holding a spoonful of pitch in your hand. It would feel solid, almost stubborn. You could tap it, press it, even try to break it. And yet if you set it down and watch for long enough, years long enough, it would begin to stretch. It would soften, it would fall, but not all at once. The pitch in the famous experiment has taken over 90 years to drop just 9 times. The last drop fell in 2014. No one was there to see it. The camera that was meant to catch it failed. That is the story of this experiment. Not just the patience of matter, but the patience of watching. The man who started this, Professor Thomas Parnell, knew he would never see the result. He set the pitch in the funnel, heated it just enough to flow, and then waited, and waited, and died long before the first drop even formed. But others took up the waiting. Other scientists, other custodians. Not researchers with specific questions, but quiet caretakers of curiosity. The experiment does not answer anything specific. It does not cure or fix or change. It simply asks, what happens if you watch something long enough? What if you give time enough space to speak? You can almost picture the pitch inside the jar slowly stretching downward, shaped not by gravity alone but by silence and time. It doesn't resist, it doesn't hurry. It simply remembers that it is not a rock but a river asleep. And the people watching year after year learn something too, not just about pitch but about themselves, about what it means to observe without interfering, to watch without needing results, to trust that even the slowest things are moving. The room around the experiment has changed. Scientists have come and gone. Cameras have been installed, failed, replaced. But the pitch remains. It darkens, cools, thickens, and continues. It waits for no one, and yet it needs watchers. Because what is an experiment without an observer? What is time if no one feels its passing? Now imagine the passage of decades in a single jar. Dust gathers, paint peels, and still the pitch moves so slowly that its motion becomes myth. The space becomes holy in its quietness, a shrine not to speed but to the long breath of nature. Science here does not race. It sits cross-legged on the floor and listens to a drip that may come tomorrow or not for another 10 years. It is easy to think of science as fast and loud, rockets, explosions, labs lit with neon. But most of science is quiet. Most of science is waiting. And some science is slower than a human life. The pitch drop reminds us that our questions may outlive us, that not all experiments end. Some just continue, like the slow curling of tree roots or the drifting of continents. They speak in a language of patience, in the grammar of years. There are many such experiments around the world, experiments designed to outlast their makers, but this one is special, not because of its complexity but because of its simplicity. It is a jar and a drop, a man and a question, a world and its watchers, and in its slowness it becomes a mirror. What else have we missed by not watching long enough? What other drops are falling quietly just beyond our patience? Let's drift deeper into this story in the next section. For now, hold the image of the jar in your mind, still, waiting, not asleep but listening, not paused but practicing the art of falling in slow motion. Now imagine yourself sitting in that same room. The air smells faintly of books and varnish. The windows let in a sleepy golden light that barely changes from morning to night. Nothing seems to move, and yet something is always moving. The pitch, the air, even your own heartbeat. Everything drifts, everything shifts, just too slowly to see. That is the quiet genius of the pitch drop experiment. It invites you not to look for answers, but to notice the question hiding in stillness. And that question is time. What is it really? Is it something we feel or something we measure? Is it a line we walk or a sea we swim in? The experiment does not rush to tell you, it simply waits. The pitch is not pretending to be patient, it is patient. It has no hurry, no anxiety, no ambition, and yet it changes. Over weeks and months and decades it stretches. It responds to temperature, to pressure, to age. Its molecules shift like people in a deep sleep, turning over in dreams. And through this, it reveals a quiet truth. Even the slowest changes are still changes. Even what seems frozen is alive in a rhythm we do not hear. Science often rewards speed. Grants have deadlines, papers have impact, discoveries race toward headlines, but the pitch drop does not care for speed, it cares only for presence. The presence of observers, the presence of continuity, the presence of a single thought stretched over a century, and in that space something happens, not a result but a relationship, between the pitch and the people, between time and attention, between the known and the unknowable. Because you can never quite predict when the next drop will fall, you can only guess, you can only wait. And so the pitch becomes a teacher. It teaches slowness but also trust. It teaches you to hold a question, not to strangle it, to let it breathe, to let it answer in its own voice, even if that voice is nearly silent. This is not just about physics. It is about patience, about the kind of listening that does not interrupt, about the kind of science that does not need control to be meaningful. Sometimes, to know something deeply, you must stop trying to make it speak, and instead make space for it to speak on its own. When you watch the pitch drop experiment, you are not watching an object. You are entering a rhythm, a heartbeat of geology, a sigh of materials we usually ignore. You are standing in a moment that stretches over lifetimes, and in doing so you are reminded that not all science fits within a single life. Some truths are slow. Some experiments need more than one pair of eyes. They need generations of watchers. They need you to be part of a relay, not a race. There is beauty in that. There is something tender in the idea that we can begin something we will never see finished, that we can offer a question to the future, knowing we won't be there to hear the answer. That kind of science is not just knowledge-seeking. It is hope. Hope that someone will keep watching. Hope that questions matter, even when no one answers right away. It is a kind of prayer made not with hands, but with time, and each drop of pitch that falls is like an amen. Now think of how this story stretches beyond one jar. In Michigan, there is another pitch drop experiment that began in the 1930s. It too has watched pitch fall, though not as slowly. In Ireland, a third one waits in a chemistry department. In each case, someone poured pitch into a funnel and waited, and someone else took over the waiting, and someone else after them. This chain of attention becomes its own kind of experiment, not in physics but in care, in scientific memory, in the ability of humans to keep asking gently, without giving up. This isn't the kind of science that makes headlines. It doesn't go viral. It doesn't cure disease, but it does something just as valuable. It teaches humility. It teaches wonder. It reminds us that the universe is not always in a rush, and neither should we be. That knowledge does not always arrive in flashes. Sometimes it arrives in drips. And so we return to the jar in Queensland. Still there, still watching, still becoming. The drop will fall eventually, it always does. And when it does, someone will mark the time, not because they were promised a breakthrough, but because they cared enough to keep the question alive. And that is what makes this experiment eternal, not its speed, not its scope, but its soul. A soul made not of pitch, but of patience. A soul passed from one mind to the next, like a candle handed across the dark. You can almost hear it, can't you? The slow whisper of motion, the gentle tug of gravity, the quiet sigh of something older than answers. It is still moving, still waiting, still teaching. All we have to do is watch. The room is quiet now, not because no one is there, but because silence has become part of the experiment. Even the dust seems to settle more gently here, as though it too understands the weight of watching. The pitch still hangs in the funnel, thick, dark, and slow beyond imagining. Another drop is forming, but no one can say when it will fall. And yet, that not knowing is part of the beauty. It leaves room for wonder. For all our instruments and equations, some of the deepest truths still live in that soft space between prediction and surprise. If you were to sit beside the jar long enough, you might start to feel time differently. The seconds wouldn't tick, they would stretch. Minutes would loosen their grip, days might feel like breaths, and in that space you would begin to understand something that science rarely speaks aloud, that knowledge is not always fast. Sometimes it drips into awareness like water through stone, slowly, patiently, unfolding itself only to those who stay long enough to listen. People have walked past this experiment and laughed. It's just a jar of tar, some say, but that's the thing with patience. It often looks like nothing right up until it becomes everything. Inside that funnel is not just pitch, but a story of human curiosity that refuses to give up just because it takes time, a story of people who built something not to finish it but to begin it, to offer it forward, to say, this is worth watching, even if it takes 100 years. And it will take time. Each drop is a decade. Each motion is a message written in the grammar of gravity. The pitch does not ask you to hurry. It does not care if you're bored. It does not care if you're ready. It falls when it is ready and only then. And maybe, just maybe, that is something we all need to learn. That readiness does not always match desire. That truth is not a reward but a rhythm. One that cannot be forced, only followed. Across the decades, the people who have watched this pitch drop have changed. Students became teachers. Teachers became memories. Still, the pitch moved. Still, the story grew. It is not the kind of experiment you do to find a headline. It is the kind you live with, like a tree outside your window. It grows whether you notice or not. But if you do notice, if you stay long enough, it becomes part of you. A quiet reminder that change is always happening, even when it's too slow to see. And isn't that the truth of so many things? The way grief fades, the way love deepens, the way mountains shift under the skin of the earth. We think nothing is happening because we cannot see it, but still the drop forms. Still the earth breathes. Still we change. The pitch drop experiment tells us this. You do not need to rush to matter. You do not need to finish something for it to have meaning. Sometimes your role is simply to begin, to pour the pitch and place the jar and step back, to trust that someone else will keep watching, that someone else will care enough to wait, that in time the drop will fall and someone will be there to witness it. And if no one is there, if the camera fails again, that's okay too, because the story will continue, because the pitch does not drop for the audience. It drops because that is what it does. It obeys the laws of physics with a kind of grace that does not depend on being seen. And in that, there is something deeply moving, a faith in natural order, a belief that even in silence, even in slowness, something is always becoming. So let the pitch keep falling. Let the watchers come and go. Let the world spin and change and forget. The pitch remembers. The pitch continues. And in every slow, sticky drop is the soft truth that science is not just about answers. It is about presence, about asking questions so beautiful they deserve more than a lifetime to answer. One day the final drop may fall, the experiment may end, the room may grow quiet again, but the lesson will remain. That time is not our enemy, that slowness is not failure, that science is not always an explosion, it is often a whisper that says, stay a little longer, watch a little closer, wait. And when the drop falls, let it remind you that even in a world that rushes, there is still power in patience. In the dim basement of Michigan State University, behind thick walls and under a forgotten layer of dust, sits a wooden cabinet that has barely moved since the 19th century. Inside it, glass bottles sleep. Not in a way that glass usually rests, but in the way old seeds do, buried, hidden, and waiting. These are not decorative jars. They are part of one of the longest-running experiments in botanical history. It began in 1879, when a botanist named William Beale walked through a field, gathered a collection of common seeds, mixed them into sand, and carefully sealed them in narrow-necked bottles. He buried them, knowing that he would not live to see most of what they would reveal. He called it an experiment in viability. In simpler words, he wanted to know, how long can a seed sleep and still wake up? Most seeds don't grow the moment they fall. They wait, for rain, for warmth, for silence, for centuries perhaps. Beale suspected they could wait longer than anyone imagined. So he set out to measure that waiting not with clocks but with lifetimes. Every 20 years, someone would unearth one of the bottles, plant the seeds, and see which ones would still sprout. no rush. No urgency, just the slow clock of nature ticking beneath the soil. Imagine holding one of those bottles in your hand. It is packed with dry sand and tiny seeds, so small you could mistake them for dust. But each one holds something ancient inside. Not a plant, not yet, but a plan, a memory, a blueprint for life that refuses to die even when hidden in darkness for over 100 years. The jar does not glow, the seeds do not hum, but still something inside them listens. They listen for the future, for the right moment, for the world to be ready. The experiment has continued through world wars, pandemics, and revolutions. Generations of scientists have passed the task like a gentle baton. Every 2 decades, they open the ground and retrieve a bottle. They plant the seeds with care, water them, and wait. Some years many grow, some years only a few, but always something wakes. Always some part of the past returns with green shoots, pushing through soil as if time were only a curtain, not a wall. It is not just a question of seed biology. It is a lesson in memory, in faith, in the idea that life is not defined by activity but by potential. These seeds are not dead. They are resting. They are remembering who they are in the quietest way possible. And when the moment is right, they begin again. Now picture the man who started this. William Beale, walking slowly through meadows in 1879, stooping to collect seeds by hand. He did not know which wars would come. He did not know how the world would change. But he knew that someone would care enough to keep the bottles safe. Someone would unearth them and read the quiet story hidden inside. That belief, that someone in the future will still care, is the heart of science. Not just discovery, but trust. Not just answers, but inheritance. The bottles sit still today. There are only a few left, buried in a secret location marked only by a small map and the memories of a few botanists. They are not behind glass in a museum. They are beneath soil, living their experiment as slowly as time will allow. And in their waiting, they remind us that patience is not the absence of action. It is the action of believing that the future matters, that what we do now will still hold meaning when we are gone. It's strange to think that a jar of seeds could be a monument, but it is. Not made of stone, but of sand and silence and waiting. Each unopened bottle is a letter to the future, written in roots and stems and leaves not yet born. And when the seeds finally stretch awake, blinking into the sunlight after a century of sleep, they will not know who planted them. They will only grow. That is their job. That is their gift. The seeds in the jar do not know how long they have been sleeping. Time does not pass for them in days or decades, it passes in silence. Their husks remain dry and whole, their shells unbroken, but inside something waits, not restlessly, not impatiently, but with the steady stillness of something that trusts the world will one day come back for it. And when it does, they will answer, with a sprout, with a leaf, with a soft push against the soil that says, "I am still here." As the years turned into decades, the Beale experiment became less about curiosity and more about reverence. Each unsealing of a bottle was not just data collection, it was a ritual, a rediscovery. Scientists, now separated from Beale by over 100 years, would gather like gardeners of history. They would dig carefully, guided by old records and fatting maps, brushing away the earth like archaeologists uncovering a message meant for them alone. And when they pulled the bottle free, they held it with both hands, not for fear of breaking it, but out of respect. Inside was not just sand and seed, it was the memory of intention. Imagine what it means to plant something that was harvested when horses pulled plows and telegrams carried words. Something that waited through electricity, through radio, through spaceflight and internet. These seeds were buried before the first car drove down the street, and they still respond to sunlight as if no time had passed. They do not know history. They do not feel forgotten. They simply continue being ready. When the seeds are planted in fresh soil, watered with careful hands and set beneath the warmth of laboratory lights, something ancient stirs. Not all awaken, many do not, but a few, a brave few, send out roots as fine as threads. Shoots begin to curl toward the sky. They grow quietly and slowly, like time knitting itself back together. And when a seed germinates after a century in darkness, it is as though the past has exhaled. As if a breath that began generations ago has finally reached the surface. The scientists who care for this experiment are not chasing headlines. There are no Nobel Prizes for waiting, but their work is no less sacred. They are part of a lineage, a long, unbroken chain of watchers and waiters. They understand that the real power of science is not speed, but steadiness. The ability to hold a question like a candle, passing it from one mind to the next without letting the flame go out. There is a beauty in the slowness of seeds, in the way they hold potential without urgency. They do not fear delay. They do not mourn lost time. Instead, they embody a kind of wisdom that we often forget in the rush of modern life, that everything has its season, and that sleep is not the opposite of life but part of it. In the quiet of the seed is the same rhythm that guides oceans, that shapes mountains, that moves stars. A rhythm too slow for clocks but perfect for becoming. This experiment, though humble, whispers something profound. It tells us that nature is more patient than we are, that life can survive absence, that knowledge does not always bloom in the presence of answers. Sometimes it grows from the willingness to keep asking again and again without knowing when or if the answer will come. When a seed sprouts from a bottle buried 140 years ago, it does more than grow, it speaks. It tells a story that no voice could carry. It says that memory lives not only in books or bones, but in the quiet code of cells. It reminds us that the future is made not of predictions, but of preparation. That someone long ago thought you might still care, that you might still be watching. And so you plant, not just for yield, but for continuity. You water not for results, but for reverence. And when the green shoot finally emerges, it is a kind of reunion. A meeting between two times, two minds, two moments separated by generations but connected by care. The Beale experiment continues not because it is spectacular, but because it is steadfast, because it teaches us that science is not always about discovery. Sometimes it is about devotion, the devotion to ask a question and then let time do the answering. And in that waiting, in that humility, we find something beautiful, a kind of science that does not shout but hums, that does not race but roots. The bottles that remain will be opened far into the future, one every 20 years until the last is unearthed in 2100. None of the original team will be alive to see it. And yet the plan continues. The rhythm endures. The seeds will be there, sleeping like stars behind clouds, waiting for light, waiting for hands, waiting to become again. The last bottle, the one set to be opened in the year 2100, lies somewhere beneath the campus soil, quietly waiting. It is wrapped not just in sand and seed, but in trust, a trust passed down through generations like an unspoken promise. Those who buried it never expected to see it bloom, and those who will unearth it may never meet the ones who planted it. Yet between them is an invisible thread, spun from the soft patience of science. The bottle is more than glass now. It is a time capsule of belief, belief that knowledge can be inherited, that care can last longer than memory, that even in a world that changes overnight, some things can move like glaciers and still matter. When that final bottle is opened, someone will kneel and brush the earth away. They may be a botanist or a student, a dreamer or a caretaker of curiosity. They'll lift the bottle gently, as though holding a heartbeat from the past. Inside, seeds will still rest, curled and dry but not gone. Some may never sprout. Others, surprisingly, will. And in their green unfolding, they will carry not just the miracle of germination, but the echo of every hand that waited before. This is what makes the Beale experiment extraordinary, not its complexity but its humility. It doesn't ask for applause. It doesn't demand attention. It simply offers a quiet question to the future over and over. Will you keep watching? Will you still care? And even now, decades before that last jar is touched, the answer is already growing. You can feel it in the slow rhythm of the soil, in the quiet work of roots beneath your feet, in the way life continues not with noise but with breath. Each seed is a pulse, a whisper, a note held out long enough to meet another listener. And when it breaks open, when it stretches toward the light, it becomes a bridge between centuries. What began as one man's curiosity has become a living chain of quiet wonder. The experiment was never about getting fast answers. It was about holding the question long enough to learn something deeper, not just about seeds, but about time itself. How it folds, how it forgives, how it carries the future inside the past like a sprout inside a shell. And what do we learn from this? That life is never really lost, that even when it sleeps, it listens. Even when buried, it remembers. Even when forgotten, it waits for the chance to begin again. And that chance may come tomorrow, or in 20 years, or 100. But when it does, if someone is there to see it, then the question will have lived long enough to answer itself. Perhaps we need more experiments like this. Not ones built for speed, but for staying. Not ones that flash, but ones that endure. Science that teaches us to listen, not just to measure. That asks us to participate not just in discovery, but in stewardship, in continuity, in the quiet bravery of believing in the long view. Because in the end, it's not about the seed. It's not about the sprout. It's about the moment between the waiting, the years held inside the bottle, the decades suspended in darkness. That is where the experiment lives, not in the results but in the space where potential sleeps and time keeps watch. And maybe as you read this, something in you is stirred too. A small seed of your own, a dream, a question, a wonder waiting for its moment. You may not know when it will grow, you may not see its bloom, but you can bury it gently. You can protect it. And maybe someone long from now will find it and water it and watch it rise, just like the seeds in the bottle, just like the science that outlives us. Let the bottle remain where it is, undisturbed and sacred. Let the soil guard its silence. Let the future hold its key. And until then, let us remember that sometimes the most powerful thing we can do is not to answer, but to wait. Not to solve, but to believe. Not to rush, but to rest beside the questions and trust that time itself will carry them forward. In this way, the seed becomes more than life. It becomes a lesson. That stillness is not empty. That patience is not passive. That even in darkness, something is always preparing to bloom. Far above us, scattered across the night like diamonds spilled on velvet, are stars that pulse in perfect rhythm. You cannot hear them, but they are ticking. You cannot see the motion, but they are spinning with more precision than any clock built by human hands. These are pulsars, dead stars that still shine with memory, and they may be the most accurate timekeepers in the cosmos. Born from the collapse of massive stars, pulsars are the remnants that remain after explosions powerful enough to light up galaxies. And though they are dead in the way we think of stars, they are anything but silent. They spin, they beam, they tick like the second hand of the sky. Imagine something no bigger than a city, spinning hundreds of times per second, sending out beams of radiation like a lighthouse in space. If Earth happens to sit in the path of that beam, we see it flash over and over without fail. Some pulsars are so regular that we use them as cosmic clocks, measuring time across galaxies with a precision atomic clocks can only admire. But these are not machines. They are the bones of stars. And still, they keep time better than anything we've ever made. To understand how strange that is, think of what a pulsar is. A neutron star. A collapsed core of matter so dense that a single teaspoon of it would weigh more than all the people on Earth. And yet, despite this weight, it dances, it spins. Not slowly, but rapidly, almost furiously, and with stunning consistency. Some spin 700 times per second, and they do not slow down quickly. They keep going, whispering their pulses through space for millions, even billions of years. Their heartbeat is slow to fade, and we, with our tiny ears, have only recently learned to listen. In the late 1960s, a young astronomer named Jocelyn Bell was scanning the sky with a radio telescope when she noticed something odd. A signal, a beat, a ticking that returned with impossible regularity. At first, they thought it might be interference. Then perhaps a satellite. Someone even jokingly called it LGM, Little Green Men, because it seemed so artificial. But it wasn't alien. It was the sky itself, a pulsar, the first one ever discovered. A star that refused to go quietly. Since then, astronomers have cataloged thousands of pulsars. Each one is different, some faster, some slower, but all of them speak in rhythm. Their signals reach us across the vast silence of space, through dust and distance, unbothered by the years. Some are so old that they've seen galaxies drift. Some are so young they still echo with the energy of their birth. But all of them remind us that time is not just a human invention. It is written into the universe itself. And so we began to use them, not just to study but to measure, to keep time. Pulsars are now used in a kind of interstellar clockwork, marking the passage of seconds across unimaginable distances. Even our most advanced atomic clocks must yield to their consistency. There are pulsars whose pulses have not varied by more than a fraction of a millisecond in decades. They are more stable than the ticking of our finest instruments, and they do this without gears, without wires, without batteries, just gravity, just spin, just the slow, deep memory of a star that refuses to forget. It's hard to grasp the scale of this. Here on Earth, we build clocks that require constant adjustment. We measure time in blinking screens and quartz vibrations. But in space, time is marked by giants, by ancient, invisible wheels that turn without friction, without flaw. Pulsars do not age like we do. They do not care for our calendars, but they still remember. They still pulse. They still count. In a way, pulsars are reminders that the universe keeps its own time. That long before we invented seconds, there were rhythms. Before we tracked hours, there were cycles. Before we built watches, there were stars that blinked. Not to light our path, but to teach us that even in the aftermath of destruction, order can emerge. Even in the wreckage of a supernova, something can survive and keep ticking. If you lie under the stars and imagine the sky not as still, but as singing, then you are closer to the truth. Each flash is a note, each pulse a whisper. The universe is not silent. It is rhythmic. It is patient. It is full of clocks older than planets, keeping time not for us but with us. And all we had to do was learn how to listen. To listen to a pulsar is to listen to the echo of a star's death told with the voice of perfect precision. The pulse is not loud, not in the way sound travels through air. Instead, it is a whisper across the electromagnetic spectrum, a gentle beat in the vastness of space, measured in microseconds but born of cataclysm. It began with an explosion, an unimaginable release of energy, a star tearing itself apart. And what remained was not chaos but a core, spinning, dense, and glowing from within. In that paradox, destruction giving way to order, we find one of the most haunting truths in science, that from the most violent endings, some of the most stable things arise. These clocks do not tick like ours. Their rhythm is not mechanical. It is elemental. It is the result of conservation of angular momentum, the same principle that keeps a spinning top balanced. When a massive star collapses, all its spin condenses. Just as a figure skater spins faster by pulling their arms inward, a shrinking star spins faster too. And that spin is preserved across time, not by intention, but by the laws of physics, written in the fabric of the universe before planets even had names. Pulsars do not just mark time. They teach us how to feel it differently, not as a race, not as pressure, but as something unfolding with grace. Their pulses travel across light years, taking centuries to reach us, yet arriving with such perfect timing that we can set our most sensitive devices by their rhythm. And they are not isolated. Some pulsars belong to binary systems, orbiting companions, stars or other neutron stars, engaged in celestial dances so delicate that entire fields of physics are tested by their choreography. In 1993, two scientists received the Nobel Prize for discovering a binary pulsar system whose timing variations proved the existence of gravitational waves. These waves, ripples in the fabric of spacetime, had been predicted by Einstein but never observed directly. Yet here, in the steady pulse of a spinning remnant, was the evidence. The pulsar, by simply doing what it always did, spinning and pulsing, revealed truths hidden for decades. It did not try. It did not chain. It simply continued, and we learned because we stayed to watch. This is the patience of science, to listen without interrupting, to watch without needing answers right away, to let something older than our species speak in its own time. Pulsars are not hurried. They are not even alive in the way we understand life. And yet, they participate in the shaping of knowledge. They are teachers wrapped in fire and silence. They are metronomes of cosmic scale. Astronomers now use networks of pulsars, known as pulsar timing arrays, to detect the slightest tremors in spacetime. Like buoys floating on an invisible sea, these pulsars bounce signals across space. And when one shifts just slightly, it tells us something has passed through, something vast, something slow, a ripple not in water but in reality itself. These measurements take decades. The data is gathered grain by grain, but from it we extract songs older than Earth, stories written in gravity. And perhaps the most humbling part is this: pulsars do not care whether we listen. They would spin whether we existed or not. Their pulses are not signals for us. They are not calling out. They are simply being. We are the ones who stumbled upon them. We are the ones who chose to stay, to point dishes at the sky, to translate their flickers into meaning. And in doing so, we learn to tell time not by the ticking of gears, but by the heartbeats of collapsed stars. In this way, pulsars are like lighthouses on a shore we cannot see. They do not light the way home, but they tell us there is a pattern in the chaos, that there are beacons even in the ruins, that even after death, a star can offer guidance, not in warmth or light, but in rhythm, in the simple, persistent act of turning again and again against the silence. And still they turn, some slow, some fast, some fading, some newly discovered. Their beams sweep across space, unnoticed by most but counted by those who care to look. To find a new pulsar is to find a new voice in the sky, a new clock added to the orchestra of the cosmos. Each one strengthens the choir. Each one deepens our understanding of the universe's tempo. So we listen. Across continents, astronomers share data, pooling years of observations into a long, slow melody. It is science in its purest form, not chasing headlines but catching whispers, not predicting but attending, because pulsars do not yield their truths quickly. They require us to return day after day, year after year, building maps from flashes, drawing meaning from regularity. And when the meaning comes, it arrives gently, not like a thunderclap but like a tide. Even now, as you sit here, pulses are arriving from across the galaxy, from places you will never visit. They reach us like letters from stars long gone, and though we cannot see the sender, we can read the rhythm. And in that rhythm we find something constant, something trustworthy, something that, for all its strangeness, feels like home. If you were to gather every clock ever made by human hands, grandfather clocks and digital watches, sundials and atomic timers, and line them up in one great hall, their tickings would still not rival the steadiness of a single pulsar. For while our clocks obey engineering, pulsars obey gravity, magnetism, and the deep, quiet laws of motion etched into the universe itself. They do not stop. They do not forget. They continue, whether we notice or not. And in that quiet persistence, they become more than timekeepers. They become monuments to endurance. Think of the sheer scale of a pulsar's devotion to rhythm. Many have been spinning since before our species walked upright. They have pulsed through the rise and fall of mountains, the births and deaths of civilizations. Their beams have swept past planets still forming, through gas clouds yet to ignite. And their light has traveled across space not for years, but for thousands and sometimes millions of years, only to fall now into our telescopes, like an ancient drumbeat reaching our ears in perfect time. Not because it was meant for us, but because it was always there. This perhaps is what makes them sacred, not in the sense of worship but in the sense of wonder. Pulsars are reminders that the cosmos is filled with clocks we did not build, messages we did not send, rhythms we did not start, but that we can still receive. When we study pulsars, we are not just looking outward. We are learning how to look inward more patiently, to hear a pattern and trust it, to wait for the next pulse even if it takes a lifetime. Because there is a beauty in something that continues when all else changes. There is hope in a signal that keeps going. Some pulsars, known as millisecond pulsars, have become so regular that scientists have proposed using them to create a universal time system, one that could help guide deep space navigation far beyond Earth's orbit. Imagine astronauts 1,000 years from now, in ships light-years away, aligning their course not with satellite signals but with the flicker of a distant pulsar. They will not see it. They may not know its name. But they will trust it, because it will still be pulsing, still steady, still ancient and kind in its own cold way. In this sense, pulsars offer something rare in science, a future that depends on the past, not on invention but on attention, because the data from pulsars doesn't arrive in one flash of genius. It arrives slowly, with each observation layered on the one before. It takes decades to know one well, 100 years to see its pattern shift. Some secrets they carry we have only just begun to read. Others may not reveal themselves for another century. And yet the story is already being written, in the silence between each beat. The people who study pulsars understand this. Their work is not loud. It is not rushed. It involves listening, charting, comparing, waiting. They are like watchmakers of the cosmos, tuning their ears to frequencies we cannot hear with our bodies but can measure with our minds. And what they find are not answers but harmonies. A kind of music without melody, composed by stars that forgot how to shine but remembered how to turn. And still they turn. Some will slow down, some will vanish. A few may collapse entirely, becoming black holes, disappearing not into nothing but into mystery. But before they go, they leave their mark, their timing, their voice. And those marks are enough to guide generations of scientists, explorers, and thinkers, people who may never see a pulsar but who will live by their rhythm. So if you ever wonder whether something small can endure, look to a pulsar. If you doubt whether the universe notices your pace, remember that it already speaks in rhythms slower and deeper than ours. The sky above is not still. It is turning. It is counting. And somewhere out there, a star that died before we were born is still spinning, still flashing, still telling the truth in pulses too steady to deny. You do not need to see it to be moved by it. You only need to know it exists, that something so far away can keep time more faithfully than anything we've built here, that long after our clocks stop, long after our cities fade, that pulse may still go on, soft, regular, undisturbed. And maybe that is the final gift of pulsars, not that they measure time, but that they remind us how to respect it, to mark it not just with alarms and deadlines, but with awe, to know that somewhere in the quiet dark, the universe is still whispering, still keeping count, still waiting for us to hear. On July 20, 1969, two astronauts stepped onto the surface of the moon, leaving behind not just footprints but questions, fine, soft, shimmering questions trapped in the dust. That dust, gray and powdery, clung to their boots, their gloves, their instruments. It stuck like ash, like memory. And it told a quiet story, that the moon, so silent and cold, had been watching for a very long time, longer than Earth could remember, longer than oceans, longer than trees. The moon's dust is ancient. It has not been swept by wind, not been washed by rain. Every grain lies where it has for millions of years, recording each collision, each breathless moment, each particle that fell from the sun. When the Apollo missions returned, they brought back more than rocks. They brought time. Sealed in metal canisters were samples of lunar soil, untouched by life, unbothered by weather. Some of those samples were opened and studied immediately. Others were locked away, sealed with care and intention. Scientists knew that future tools would be better, that future minds would see more clearly. And so they waited. For 50 years, some of that dust slept in storage, its secrets suspended in silence. In 2019, on the 50th anniversary of Apollo 11, a small group of scientists finally opened one of the long-sealed samples. The dust had not changed. It had not faded. It had not aged. It had simply waited. And when it was opened, it told its story with clarity, a tale of cosmic winds, of solar particles, of micrometeorite impacts that Earth's atmosphere would have erased. The moon does not forget because it has nothing to forget with. It simply remembers by holding still. And so science found itself in a rare kind of relationship with material that had waited longer than most lives and with questions that could only be asked once the waiting was over. The researchers approached the sample with reverence, not because it was fragile but because it was patient. It had waited half a century to be heard again, And now, under electron microscopes and spectrometers, it spoke softly of ages long past, of heat and light, of silence, of stillness that saw everything. The moon's dust is not like Earth's. It is sharp, angular, unweathered. On Earth, dust becomes round, polished by wind and water. On the moon, there is no erosion, only impact. Each particle is a fossil of collision, a record of violence left untouched. When you touch lunar soil, you are touching the remains of explosions too small to hear, too ancient to name. And yet they left their mark, not just in craters, but in the very shape of the dust itself. Some samples contain tiny glass beads, spheres formed in brief flashes of intense heat when meteors struck the surface and melted the stone. These beads hold clues about the moon's volcanic past, about its atmosphere, or lack of it, and about what the early solar system was like. In these grains are messages not just from the moon, but from the time when planets were still forming, still molten, still choosing their paths. And we are only just beginning to read them. Samples from Apollo missions are finite, precious. They are not used carelessly. Each one is studied with the kind of attention usually reserved for sacred objects, because they are sacred in their slowness, sacred in their silence. They offer what no telescope can, a touchable piece of elsewhere, a physical trace of a place that, until very recently, we could only see. And now, held in labs and vaults, the moon sits quietly on shelves, still telling its story in the language of minerals and motion. The decision to keep some samples sealed for decades was not hesitation, it was foresight. It was the belief that science is not just about the now. It's about building bridges between the present and the possible. The scientists in 1972 who sealed those containers knew they would not be the ones to open them. They were not writing conclusions. They were writing invitations. And that invitation reached us decades later, still crisp, still clean, still waiting to be accepted. That is the patience of science. It is not just a willingness to wait. It is the wisdom to know what can be learned now and what must be learned later. It is the humility to step back and say, I do not yet know, but I believe someone will. And so, the dust waited. And when it was finally studied, it gave us new insights, not because it had changed, but because we had. The instruments we used in 2019 did not exist when the sample was sealed. The questions we asked could not have been imagined then, but the dust had been ready the whole time. That is the quiet partnership between matter and mind, between what is and what we are finally able to see. To hold moon dust in your hand is to touch time itself, not just time measured in years or calendars, but time measured in stillness, in how long something can remain unchanged. The moon has no air to stir its surface, no water to carve it, no life to tread it. So the dust you cradle in your palm may have lain exactly that way for millions of years before being scooped into a metal container by a suited figure from Earth. That kind of stillness is not found anywhere else we've touched. It's a kind of cosmic memory, unshuffled, unspoiled, left in the same quiet arrangement written by the solar wind and tiny, unrelenting collisions with space debris. When we study that dust, we're not just learning about the moon, we're learning about survival, about what it means to endure in silence, about how the simplest things, dust, rock, shadow, can become profound just by outlasting everything else. The particles themselves speak of a world that never learned to forget. They carry tiny bits of iron, of glass, of melted minerals that cooled in microseconds and were then locked, untouched, beneath the harsh light of a sun that never sets or rises. On the moon there is only shadow or glare. There is no dusk, no dawn, and yet it keeps time in its own way, in layers, in quiet scars, in the depth of a crater and the tilt of a pebble. Every now and then Earth has sent probes and rovers to the moon's surface. Each mission brings new instruments, new goals, but they all carry something old, the dream of understanding a place that has seen our planet from afar for 4 billion years. Imagine that. The moon has watched Earth's storms without feeling their rain. It has watched forests grow and vanish. It has witnessed the rise of life, the forming of oceans, the flickering of cities, all without blinking. And all the while it has kept its surface, its dust, its ancient silence. That's why the samples are so powerful. because they are not just soil, they are witnesses, carriers of solar history. Scientists use them to study radiation that bombarded the moon's surface thousands or millions of years ago. Unlike Earth, where atmospheric shielding and erosion blur these signals, the moon preserves them. Frozen in its soil are records of cosmic events, of solar flares and space weather, written in charged particles embedded in minerals. Every speck is a capsule of past energy, a message from a time when the galaxy danced differently. When scientists opened one of the sealed samples in 2019, they weren't just looking for rock composition. They were looking for history, for unknown elements, for volatile gases, for traces of ancient processes locked in place because no air had ever touched them. Specialized instruments carefully extracted every molecule, every signal, as if unwrapping a letter from the past. The lunar soil responded, not with fireworks but with gentle clarity. It had been waiting for someone who could finally read it. And now, with new technology, we can. We're developing sensors that can analyze atoms one at a time, microscopes that can see the structure of a single crystal grain. And with these tools, we are rereading the moon's quiet story, line by line. We are discovering that the dust holds water, trapped in minerals, that it holds clues about the moon's volcanic past, its once molten heart, long since cooled, that it may even help us learn how to build life-supporting environments if we return to stay. Because the moon isn't just a memory, it's a beginning. A place we may one day walk again, not as visitors, but as students of patience. The same dust that clung to Neil Armstrong's boots may cling to those of a child not yet born, who will step out onto the surface decades from now and see Earthrise for themselves. And the soil will welcome them as it did the first, unchanged, unmoved, holding its breath for the next chapter. What science gains from such stillness is more than data. It's a lesson in humility. We like to think of knowledge as something we extract quickly, as answers we hunt. But some truths reveal themselves only to those who wait, to those who know when not to touch, not to rush, not to disturb. The scientists who preserved those samples knew that some questions require more than curiosity. They require faith. Faith that the future will care, that someone will return, that the story will be continued by hands not yet imagined. In this, lunar soil teaches us about ourselves, about the parts of science that are not measured in breakthroughs but in continuity, in sealing something away not to hide it but to preserve its voice until we are ready to listen. The moon didn't change while we waited, but we did, and that change made all the difference. So we return with better tools, deeper questions, and quieter minds, not to conquer but to understand, not to claim but to remember, that somewhere in the silence of the moon a record is kept, not in ink, not in language, but in dust. In the years to come, more of the moon's samples will be opened, not all at once but slowly, like turning the pages of a book that took eons to write. Each bottle of soil, each pouch of dust, carries with it a silence that is not empty but full. Full of memory, of starlight trapped in stone, of cosmic storms etched in grain. These samples, sealed with hope and foresight, are more than relics. They are messages, not messages sent with words but with waiting. Left behind not by a people in haste, but by a people learning the value of patience. And that patience is bearing fruit. New analysis techniques, once only science fiction, can now read the lunar soil with tenderness and clarity. Mass spectrometers that detect the lightest gases, electron microscopes that map the structure of a single grain, computers that model the entire history of a rock from its atomic behavior. The moon is no longer a distant sphere in our sky. It is a growing archive, a library of silence whose shelves we have just begun to browse. What we find there reshapes our understanding not just of the moon, but of Earth, of the solar system, of ourselves. We learn that the moon was once active, volcanic, restless, that its crust carries fingerprints of ancient impacts, of molten tides frozen in time, that the same dust now resting in vacuum once glowed with heat. And in this, we see our own reflection. For we, too, hold layers. We, too, carry stillness above a history of motion. The moon's story becomes a mirror, a quiet one, unflinching in its age, generous in its patience. Perhaps the most haunting lesson the moon teaches us is this: that silence can be a container of knowledge, that absence of change can be a gift, not a void. On Earth, we must fight against erosion, growth, decay. But on the moon, what land stays? What strikes leaves its full signature? A crater does not fill in. A footprint does not fade. When we placed instruments on its surface in the 1970s, they continued sending signals for years. And even when they fell silent, they remained, like old lanterns unlit but unbroken. This permanence transforms every object we leave behind. A flag, a bootprint, a mirror to reflect lasers from Earth. They are not trash or trophies. They are echoes. Each one says, "We were here and we listened." Each one becomes part of the moon's memory, woven into its dust. And maybe someday someone will walk there again and find those echoes untouched, waiting to be remembered. The next generation of scientists, engineers, and dreamers are already preparing. Lunar missions are on the horizon. More samples will be collected. But with them, something new, an understanding that the moon is not just a destination but a witness, a record keeper, a place where time moves without rush and knowledge ripens in silence. As we return, we must bring not only new tools but new humility. We must listen longer. We must disturb less. Because the moon does not interrupt. It does not correct or erase. It only remembers. And what it remembers is astonishing. We may one day use its soil to build shelters, to grow food, to find water frozen in shadow. But even then, even as we shape it to our needs, we must remember that it has shaped us too. It has taught us to wait, to seal away what we love so it can be known more fully later, to trust that knowledge matures like fruit, not on our schedule but in its own season. In the laboratories where lunar soil is now studied, there is a kind of reverence. White gloves, clean air, slow movement, as though each grain were sacred. And perhaps it is. Not because it is rare, but because it is unchanged. It is the world before noise, before breath, before rain, a world that saw the beginning and remained to tell it. And so the moon waits still. It waits with every sealed sample, every crater, every unshaken footprint. It waits for us to learn not just how to leave Earth, but how to return with grace, to open what has been sealed, to listen to what has been quiet, to ask not just what we can extract, but what we can hear. For science at its best is not the loud announcement of truth. It is the gentle uncovering of stories that were always there, stories that waited not for fame, but for readiness. The moon's dust, unchanged for millennia, speaks softly, but in that softness is a power that outlasts us all. So let the canisters remain sealed until the time is right. Let the dust sleep a little longer. Let the moon teach us, grain by grain, that in stillness there is story, that in waiting there is wisdom, and that in silence the universe speaks. In a quiet lab, somewhere beneath the hum of lights and the faint scent of metal and ozone, scientists are doing something extraordinary, not by speeding things up but by slowing them down, not by igniting explosions but by removing heat, all of it, bit by bit, until what remains is almost nothing, until atoms barely move, until time, in a strange way, seems to hesitate. This is the realm of ultra-cold physics, where temperatures fall not just below freezing, but to billionths of a degree above absolute zero, a place colder than anywhere in space, a place not found in nature, a place we had to build. To imagine this cold is to imagine stillness beyond imagining. At absolute zero, 0 Kelvin, motion itself disappears. Not just the shiver of a molecule or the twist of an electron, but all vibration, all thermal noise. It is the temperature at which entropy no longer drives movement, a theoretical floor to all motion in the universe. We've never reached it, not fully, but we've come astonishingly close, just a few billionths of a degree away. And we've done it on lab benches, in metal chambers smaller than a kitchen sink, using beams of laser light and magnetic traps as delicate as spider silk. This perhaps is the great irony of ultra-cold physics, that to reach the coldest temperatures ever known, scientists must wield light. Laser cooling sounds like a contradiction, but it works by slowing atoms with photons, tiny particles of light, gently nudging atoms until they stop bouncing, until they hover, until they enter a state that no longer resembles the chaotic dance of warm matter, but something else entirely, something like a whisper of existence. In this state, strange things happen. Matter becomes waves. Atoms, normally individuals, begin to act as one. They merge into a single quantum state, forming what is known as a Bose-Einstein condensate. It is not solid, not liquid, not gas. It is a cloud that behaves like a single entity, drifting in a vacuum chamber, shining softly under the glow of laser light. It was predicted in the early 20th century by Einstein and Bose, but not observed until the 1990s. Because to make it real, we had to learn how to wait, how to listen to the cold. What happens inside that chamber is not violent, it is not fast. It is instead precise, graceful, a series of slow reductions, cooling, trapping, slowing, aligning. At each stage, the atoms lose just a little more energy. Their dance becomes slower, their collisions softer, their identities blurrier, until at last they stop acting like separate things and become one shared ripple, a quantum poem of matter, a collective breath of the universe at its quietest. These Bose-Einstein condensates are not just curiosities. They allow us to study the behavior of matter at its most fundamental. They help us test the edge of quantum mechanics, explore the nature of superfluidity, and peer into behaviors that only emerge when motion is nearly absent. When the usual distractions of thermal energy are gone, the world reveals new shapes. Patterns that were hidden by heat become visible. Order appears not because we force it, but because we wait for it. And that waiting, that patience, is not passive. It is a kind of craftsmanship, a discipline of letting nature speak slowly and building the silence in which it can be heard. The scientists who create these ultra-cold environments do so not with brute force but with gentleness. They cool with light. They measure with shadows. They hold atoms still using invisible hands made of magnetism. It is like trying to catch fog in a net of moonbeams. And yet they succeed. In one experiment, researchers cooled a gas of potassium atoms to just 500 picokelvin, 5/10 billionths of a degree above absolute zero. No place in the universe, not even the dark between stars, is so cold. And yet, there in that chamber, under controlled conditions, we created a piece of the universe more still than space itself. Not because we wanted to dominate nature, but because we wanted to see her more clearly, to see what matter does when all the noise is gone. And what we found was beauty. Waves of atoms drifting like fog, coherence across distance, superfluid vortices, tiny whirlpools in a fluid that has no friction. The rules we take for granted, the categories we draw between gas and solid and liquid, all begin to melt in this cold. The familiar dissolves, and what remains is something purer, quieter, not broken but simplified. In the coldest labs on Earth, science becomes something close to meditation. Each adjustment is slow, each signal faint, time stretches, breath slows, you wait for the system to cool, you wait for the atoms to align, you wait for the condensate to appear. And when it does, it is not with a flash or a bang. It is with a soft bloom, a ghost in the dark, a shape where there was only scatter before. You see it not with your eyes, but with your instruments. And even then, only if you've prepared carefully. Only if you've been gentle. This is the cold that teaches. That shows us not what happens when we speed things up, but when we slow them down beyond the point we thought possible. It is science done in whispers. It is the patience of freezing light, of cooling motion, of waiting for the world to become still enough to show its true shape. Inside the coldest chambers on Earth, something remarkable begins to happen, not just in the behavior of atoms, but in the rhythm of the room itself. Scientists speak softly, movements slow, computers tick in quiet cycles. There is no rush, no chase. Everything waits for the cold to arrive, as if the lab has agreed to hold its breath. Because when you approach absolute zero, even time feels different. Seconds stretch, minutes linger. Progress is measured not in speed, but in stillness. The lower the temperature, the higher the precision. And this precision opens a door, not to chaos, but to a delicate, hidden world where matter behaves like thought. In that world, atoms no longer behave as if they are separate. Instead, they become something collective, A Bose-Einstein condensate is not many atoms, it is one wave, a field, a singular voice formed from countless quiet ones, and that voice whispers stories that ordinary temperatures never allow. In one lab, rubidium atoms are cooled until they fall into sync, forming standing waves like ripples frozen in place. In another, sodium atoms swirl in patterns so perfectly choreographed, they seem to defy individuality. It is like watching dancers who have forgotten where one ends and the other begins. And then there are superfluids, liquids so cold that they flow without resistance. Pour them into a container and they climb the walls, slipping up and over the rim like they're searching for freedom. They defy friction. They circle endlessly, never slowing. These are not just fluids, they are the poems of motion. Their existence proves that at the edge of cold, nature stops obeying the rules we expect. The same atoms that once bumped and bounced now move with the grace of unity. These experiments are not done for spectacle. They are done because within this strange cold lies the key to understanding everything else. Temperature is more than comfort, it is energy. And when you remove energy, you reveal structure. You strip away the noise. You see atoms in their quietest state, electrons in their cleanest orbits. You see the quantum world not as a theory, but as a landscape you can actually touch. And that landscape, even in its simplicity, is full of wonder. Scientists have found that under these ultra-cold conditions, matter can simulate other systems. Want to study the early universe just microseconds after the Big Bang? Cool your atoms. Let them mimic the quantum fields of creation. Want to understand superconductors or black hole analogs? Cool again. Let the condensate guide you. The lab becomes a universe in miniature, a stage on which nature plays out her secrets, dressed in stillness. And all of this begins with waiting, with lasers that push atoms back and forth, slowly removing their momentum, with magnetic fields that cradle them like invisible hands, with vacuum chambers that keep every stray molecule at bay. It's a process that takes hours, sometimes days, a process that can be undone in an instant if disturbed. One bump, one unexpected vibration, one tiny shift in temperature, and the whole delicate state collapses. That is why ultra-cold physics is not just a science of instruments, but a science of care. The people who work in these labs know this. They do not chase the cold, they court it, they listen to it, they adjust mirrors by fractions of a degree. They realign beams, recalibrate traps, wait for noise to settle. They learn to hear the hum of the equipment not as background, but as feedback. They learn to feel when the atoms are ready. And when the moment comes, when the cloud collapses into one, there is no cheer, no alarm, only a small click, a graph, a soft signal on a screen. And in that signal, a miracle. Because what they've captured is not just low temperature. It is coherence, harmony, a state where particles behave not like individuals but like notes in a chord. The smallest deviations are studied. The tiniest fluctuations are recorded. It's not about getting the same result over and over, it's about understanding how even the smallest changes matter. In the cold, every detail speaks. And as science listens, it begins to imagine. Could we use these condensates for computing, for sensing gravity waves, for building clocks more accurate than anything yet devised? The answer, slowly emerging from the stillness, is yes. Already, atomic clocks cooled by lasers are accurate to within 1 second every 300 million years. These clocks do not tick, they shimmer. Their rhythm comes not from gears, but from the vibration of atoms in perfect stillness. In the future, such precision may guide spacecraft through deep space. It may detect tremors in spacetime itself. It may even help us understand the link between quantum mechanics and gravity, a puzzle older than most of the theories we hold today. But none of this would be possible without first learning to wait, without building spaces quiet enough, cold enough, still enough to let the universe whisper. The coldest labs on Earth are not empty. They are filled with questions too subtle for heat. And those questions, about matter, about motion, about the nature of reality, cannot be answered in haste. They wait in the chill. They wait in the quiet. And when we are ready, they bloom like frost in morning light. In this cold, time does not stop, but it becomes something else, less like a river, more like a pond after the wind has passed, still. reflective. It is in this space where energy is nearly absent that science dares to ask the quietest questions. What is the boundary between classical and quantum? What happens to identity when particles act as one? Where does warmth begin? These are not questions with quick answers. They are long, slow echoes that return only when the world is hushed enough to hear them. And so we keep cooling, not just for the sake of temperature but for the sake of insight. Each fraction of a degree closer to absolute zero reveals something hidden. It reveals the truth behind turbulence, the reason for resistance, the shape of simplicity itself. The colder the system becomes, the more visible its secrets. Superconductivity emerges where electricity flows without loss. Quantum tunneling becomes observable. Phase transitions unfold with the elegance of poetry, sharp, sudden, and yet perfectly expected. These transitions, these moments when matter shifts form without warning, are like thoughts crystallizing in the dark. One moment the atoms are merely gas, floating, free, unpredictable. The next they are unified as if remembering a shape they were always meant to take. This isn't freezing like water to ice. It's deeper than that. It's a change in behavior, not just form. A surrender to coherence. A kind of silent agreement among particles to stop acting alone. In this frozen silence, scientists become more than observers. They become caretakers of an almost sacred stillness. The chambers they work with are sealed against noise, vibration, stray radiation. Everything is shielded. Everything is controlled. Even the air itself is absent, vacuumed away to give atoms the room to become slow. Every experiment is a dance with fragility, one that requires hours of preparation for moments that last only seconds. And yet, those seconds change our understanding of everything. It is here in this edge-of-zero world that new kinds of matter are born. Quasi-particles, topological states, spin liquids, concepts that exist only when the universe is held still enough to dream. These are not the materials we find in everyday life. They are the hidden chapters in nature's story, written in a language too quiet for warmth. They require cold to exist, like snowflakes that vanish at the first touch of breath. And once glimpsed, they change us. They show us that reality is broader, stranger, softer than we imagined. Even space itself becomes different in this cold. The Casimir effect, a mysterious force between two uncharged metal plates, emerges only in a vacuum so clean it can barely be described. Zero-point energy, the baseline hum of the quantum world, becomes measurable. Gravity, magnetism, motion, all reveal nuances we miss in warmer, faster settings. The cold is not emptiness, it is clarity. And as clarity deepens, so does our wonder. Because these experiments are not only about atoms and waves, they are about time, about how long we are willing to wait for the universe to reveal itself. The process is never quick. It requires alignment, calibration, patience beyond comfort. Some results take days to capture, weeks to verify. The data is often faint, scattered across noise, but within that noise, if we are gentle, a pattern emerges. The people who devote their lives to this science know that the most valuable truths cannot be forced. They must be invited. They must be hosted with care. And in this way, the coldest place on earth becomes one of the warmest acts of faith. A belief that waiting matters, that slowness matters, that there are things worth seeing that can only be seen by those who stay. In a time when everything urges speed, ultra-cold labs move in the other direction. They show us that insight can come not through acceleration but through stillness. That understanding doesn't always follow pressure, it follows presence. The presence of hands that adjust quietly. The presence of minds that observe without demanding. The presence of hearts that understand that science, at its most powerful, is not a race, but a relationship. So the atoms rest, the lasers hum, the graphs drift into alignment, and in that moment, so fleeting, so fragile, we glimpse something timeless. Not just the behavior of matter, but the memory of the universe. A memory that says, before there was light, before there was fire, before motion was born, there was this. A stillness so complete, it holds the shape of everything that would follow. We may never reach absolute zero, but in trying we become more attentive, more patient, more capable of hearing the smallest truths. And that is what the cold gives us, not just numbers or graphs, but a discipline of wonder, a way of looking deeper, a way of waiting longer, a way of asking again and again in silence, "What are you?" And hearing in silence just as deep the universe whisper back, "Come closer and I'll show you." In the middle of a quiet forest, beneath a canopy of leaves that rise like green cathedrals into the sky, there stands an old oak. It has seen 100 winters. It has felt the hush of snow, the burn of summer droughts, the brush of deer against its bark. But once, just once, it felt something else. A bolt of lightning. A flash so bright and sudden it split the air in two. It struck without warning, racing from cloud to crown, coursing through its limbs in a white-hot wave, then vanished as fast as it came. To the human eye it might have left only a scar, a line of missing bark, a charred limb, but deep within the wood, in rings no one sees, the tree remembers. This is not poetry, it is science. Trees, it turns out, are living records, not just of time but of trauma. Each ring they form each year tells a story of rain or drought, of warmth or frost, of fire or peace. And when lightning strikes, the tree does not forget. It carries that memory inward, in disrupted cell walls, in altered chemistry, in rings that are misshapen, split, darkened. Long after the wound has healed on the surface, the tree still holds the event within its grain, like a whisper wrapped in silence. This ability of trees to remember is part of the science of dendrochronology, tree ring dating. Scientists can read the history of forests, of climate, even of individual events by studying the patterns in wood. Not just the thickness of rings, but their shape, their density, their anomalies. And among the most dramatic of these are the silent scars left by lightning. When a lightning bolt hits, it sends a surge of current through the water-filled tissues of the tree. The sap, rich in minerals, becomes a conductor. The heat can vaporize water instantly, causing cells to explode. Bark may peel away in long ribbons. Branches may fall. But even when the damage seems small, the change within is vast. The tree reroots its growth. It repairs what it can. And in doing so, it leaves behind a mark, not of destruction, but of resilience. That mark becomes part of the tree's memory, and sometimes that memory becomes part of ours. There are trees on battlefields that remember cannon fire, trees in cities that hold the memory of bombs, trees in quiet parks that carry the shock of lightning from decades past. They stand, silent and still, and yet within them pulses a record of violence, of survival, of change. Scientists have begun to study these signals more carefully. Using tiny borers, they extract slender cores of wood no wider than a pencil from living trees. These cores are then analyzed ring by ring, year by year, like pages in a diary. And when lightning has struck, its entry is unmistakable. A sudden distortion, a ring that curves unnaturally, a spike in isotopes, a gap, a twist, a shadow in the wood. But the story doesn't stop with lightning. Trees remember more than strikes. They remember radiation. Some trees near Chernobyl show altered ring structures from the years after the meltdown. They remember floods, growing thinner rings when roots are waterlogged, thicker ones when rains are kind. They remember fire, faint black layers where ash settled on leaves. They remember insect plagues and windstorms and even eclipses, when light changed so suddenly the photosynthesis stuttered and growth paused. All of this becomes part of the tree, not metaphorically but physically. It is encoded in its tissue, in its carbon, in the very alignment of its cells. A tree is not just a plant. It is a living archive, a slow-growing library of events too quiet, too long, too still for human memory to hold. And in that silence it teaches us something profound, that patience is not just waiting. It is recording. It is absorbing change without surrendering to it. Lightning, though rare, is a perfect symbol of this. It is sudden, loud, violent. It seems to erase, but the tree does not treat it as an end. It treats it as a message, a thing to be understood, integrated, survived. The damage does not make the tree weaker. In some cases, it makes it stronger. It builds around the wound. It shapes new growth to protect what was lost. It heals, but it never forgets. In this way, trees become storytellers, not with voices but with layers. They do not need to speak to share. They only need to grow. And in their growth, they hold the memory of 100 storms, 1,000 mornings, 1,000,000 moments of light, including that one bolt, that one sharp flash, that one instant when the sky reached down and touched them and everything changed. But still they stand, still they grow, still they remember. The idea that trees carry memory is not just poetic, it's measurable. And when scientists read these memories, they see not just one tree's life, but the memory of entire ecosystems. One tree may remember a lightning strike. A forest may remember a century of climate change. A continent of trees may record a millennium of wind, rain, fire, and ash. Every ring is a line in a biography. Every scar is an unspoken word. But taken together across thousands of trees, these lines become a chorus. A record of the world written not in ink, but in patience. Deep in the heart of redwoods, the world's oldest trees, some of these stories stretch back nearly 3,000 years. Lightning has struck them more than once, and still they grow. When researchers bore into them carefully, respectfully, they find not just the past but patterns. Events that happened before written language, before cities, before countries. Events like the eruption of Mount Mazama, or the solar flare of 774 AD, or the Little Ice Age, all silently captured in fibers of wood. What is most humbling is that the trees did not mean to remember. They simply could not help it. They were alive, and so they carried the marks of everything they lived through. One of the most intriguing findings in recent decades has been the way lightning affects more than just the tree it strikes. When a bolt travels through a forest, its electromagnetic pulse can influence nearby trees too. It might not burn them or break their branches, but it can still leave a subtle imprint. Changes in growth rate, small distortions in their rings, a brief drop in photosynthesis, visible only under close measurement. The trees, in effect, respond together. Not loudly, not visibly, but biologically. As though the forest, in its own quiet way, shudders at the impact, then continues on. This shared response hints at something deeper, something scientists are only beginning to explore. That trees do not live in isolation, that their roots, their leaves, even their inner chemistry are connected in ways we do not fully understand. Through underground networks of mycorrhizal fungi, trees share nutrients, signals, warnings. Some researchers believe they may even share stress. And if that's true, then one tree's memory may ripple through many others. A lightning strike in one corner of a forest may echo in another, not as a scar, but as a whisper, a signal passed from root to root. It makes us wonder, how many memories are hidden beneath the soil, never seen in rings, but still pulsing in the quiet currents of shared life? The implications reach beyond forests. Scientists have started to use tree rings to reconstruct climate records thousands of years long, not just temperature and rainfall, but even solar cycles and atmospheric chemistry. In 2012, a team found evidence in Japanese cedar trees of a massive solar flare that occurred in the year 775. The radiation left a spike in carbon-14, an isotope that trees absorb from the air. It had been there all along, quietly waiting in a ring of wood, unnoticed for over 1,000 years. The lightning strike, then, is only one type of memory. Trees carry other kinds, memories of air, of radiation, of carbon, of heat. They remember volcanoes, they remember floods. They remember when the seasons shifted, when humans cleared land, when animals disappeared. And unlike our memories, theirs do not fade. They remain sharp. They remain physical. They are etched in grain and fiber. We don't need to ask the trees to remember. We only need to learn how to read. In reading them, we also read ourselves. The trees have stood longer than our histories. Some have seen empires rise and fall. Some were seedlings when pyramids were built. Some have survived every war, every plague, every drought. And they survived not by resisting, but by adapting. They did not forget their wounds. They wrapped them. They built around them. And in doing so, they grew. This resilience is not loud. It does not shout its strength, it whispers it, in slow rings, in quiet cells, in the calm persistence of leaves returning every spring, even after lightning, even after loss. The trees do not erase what hurt them. They incorporate it. They make it part of the story. They do not pretend the past did not happen. They carry it forward quietly, year after year, deeper into their hearts. And perhaps in that there is a lesson for us, that survival is not forgetting, that healing is not erasing, that the marks left by fire, by storm, by sorrow can become part of our shape, not our shame. The trees show us how to remember without breaking, how to grow around pain without becoming hollow, how to stay rooted even when the sky falls. So when you walk through a forest and feel something ancient in the air, know this: you are surrounded by memory, silent memory, deep memory, not of human words but of weather and light and change. The trees are not speaking, but they are telling, and if you lean close enough and wait long enough, you may begin to hear them. There are trees alive today that were struck by lightning before the printing press was invented. Trees that have weathered centuries of storms, not by standing rigid, but by bending, healing, remembering. Each season that passes adds another line to their record, another echo of the world's breath captured beneath the bark. And though we cannot see it from the outside, each one of these memories is stored in careful, quiet order, inside concentric rings that never forget. The lightning does not return, but its imprint remains. The fire is gone, but the tree still holds its shape. And what is most beautiful is that trees do not resist this memory. They do not flinch from the scar, they allow it. They accept the change. They move forward not as they were before, but as something new, something shaped by the storm and stronger for it. The line left behind is not a mark of weakness, but of wisdom. It says, "Something happened here, it mattered, but I am still here, I still grow, I still reach." Some of the oldest trees on Earth, bristlecone pines, yews, baobabs, carry hundreds, even thousands of years of these silent testimonies. They have lived through lightning, yes, but also through droughts that lasted lifetimes, through migrations of animals long extinct, through changes in atmosphere and light. Their rings stretch like timelines. Their trunks thicken with the weight of experience. They are, in every sense, living chronicles. And so scientists return to them again and again, not just to ask about weather or radiation, but to glimpse the long view, to see what survival looks like across ages. In Scandinavia, researchers have studied trees that show signs of climate anomalies from volcanic eruptions in the tropics, clouds of ash that traveled the globe and dimmed the sunlight. The trees recorded the darkness, not in words, but in growth that slowed, paused, then recovered. In the tropics themselves, trees bear witness to shifting monsoons, to decades of flood and famine, all kept quietly in the turn of a ring. We humans mark time with watches and calendars. Trees mark it with growth and silence. But in the end, both are telling the same story, what has passed and what it meant. And when we study these arboreal records, we begin to understand that nothing is ever truly lost. That memory lives not just in minds or machines, but in the shape of nature itself, in the scars that trees carry without shame. Lightning is one moment, but memory is made in the years that follow. The years where the tree continues, when it sends out new branches, when it forms new buds. The wound becomes part of the pattern, not a glitch but a curve in the music. And that music continues, softer perhaps, but wiser. Each ring forming around the last, carrying forward not just damage but resilience. In our own lives, we often seek to forget what has hurt us, to erase the signs of impact, but the trees teach a gentler way, to remember without reliving, to grow without discarding, to carry what happened not as burden but as shape. The past is never undone, but it can be embraced, wrapped in layers of new living wood, transformed not by denial but by growth. So the forest stands full of quiet witnesses. Some bear lightning scars deep in their core. Others carry only the gentle curves of long life. But each one is remembering. Each one is shaping memory into matter. And when the wind moves through their leaves, you might imagine it's a kind of whispering. Not words, but rhythms. Not speech, but understanding. These trees will outlive us. They will go on recording year by year as we go about our lives. And when they fall, their stories will not vanish. Their rings will remain, in cross-sections studied by hands not yet born, in samples taken from stumps and trunks, In the scent of old wood and the shape of its lines, we will read them, and we will remember. Because memory is not just what we choose to keep. It is what the world keeps for us, in stone, in ice, in stars, and in trees, especially in trees. So when you next see a tree standing in stillness, remember, it has already survived more than you know. It has already written the story of lightning and loss into its very bones, and still it grows, still it breathes, still it waits for another season, another ring, another whisper from the sky. The trees do not forget, and neither should we. It is easy to think of glass as solid. We touch it, tap it, see our reflections in its surface. It rings like stone when struck. It holds shape, it resists. But deep beneath that still surface lies a strange and subtle truth. Glass, despite appearances, is not a solid in the way we imagine. It is a liquid, a very, very slow liquid, one that flows so slowly it takes centuries for the movement to show. A material that looks frozen in time, but is actually slipping forward ever so slightly, like a glacier in the shape of a window pane. This idea has fascinated scientists and historians alike. In ancient cathedrals where stained glass windows have stood for hundreds of years, researchers notice something odd. The glass is often thicker at the bottom than at the top, as if it had gently sagged under its own weight, creeping downward across centuries. This doesn't mean it's dripping or oozing. The change is almost imperceptible, but it suggests a truth we rarely consider, that stillness is not the same as stasis. That things can move even when we cannot see them move. Glass exists in a state known as an amorphous solid. Its molecules are arranged not in neat crystalline grids like in salt or quartz, but in tangled patterns more like a frozen liquid. This structure gives glass its clarity, its rigidity, its shimmer, but it also gives it its mystery, because it means the molecules are not locked into place. They are merely resting. Their arrangement is not perfect, only paused, and over long enough timescales they shift. To understand this, imagine a jar of honey left in the cold. It stiffens. It becomes almost solid, but wait long enough and gravity will still draw it downward. Now imagine that jar is made of atoms and the cold is eternal and the waiting spans not minutes but millennia. That's glass. It holds shape but never truly settles. It is always reaching for rest. This kind of movement is so slow, we once believed it didn't happen. For centuries, we called glass a solid without question. Only recently have we begun to explore the subtle dances of its atoms, the way they wobble, lean, nudge against each other. Not enough to drip, not enough to bend, but enough to show over decades and centuries that nothing is truly still. This realization transforms how we see the objects around us. That mirror on the wall, it is not timeless. It is aging, flowing, changing. The old glass in antique buildings. It carries a record not just of what it reflects, but of what it has become. And this movement, this almost invisible drift, becomes a new kind of story, a story of patience embedded in matter. Scientists study glass to understand more than just its history. They study it to grasp the nature of time itself. Glass transitions challenge our definitions. It is neither a perfect solid nor a flowing liquid. It sits between states, occupying a liminal space that resists clarity. And in doing so, it reflects something back to us, not just our image, but our own uncertainty. Our desire to define, to categorize, to say what something is. Glass reminds us that nature does not always obey our labels. In laboratories, researchers now use high-speed cameras and atomic probes to measure the motions inside glass. They observe the slow migration of particles, the subtle rearrangement of bonds. What they find is that even when all appears calm, movement remains. It is not chaos. It is not turbulence. It is the slow rearrangement of possibility. There is something humbling in this. To realize that the glass we look through is looking back, not with eyes but with time. That it is not frozen, only flowing in ways we cannot yet perceive. That it carries not just light but age. And in that age a memory of formation, of heat and sand and fire. Every pane began as liquid. It was melted, poured, cooled. And though it hardened, it never truly stopped being liquid. It only slowed. The slowness is the key, because in glass, as in the oldest experiments, change does not shout, it whispers. It does not break free, it settles inward. And in that settling we find a new kind of science, one that does not race but rests, one that does not demand answers but waits for the material to speak. And glass does speak, in cracks that spread like lightning, in stress patterns visible only under polarized light, in the way old windows ripple when you look through them at just the right angle. They hold the history of their own making. They remember the cooling, the pressure, the moments of tension held inside. They are not perfect. They are not inert. They are, in their own slow language, alive. To study glass is to study time itself, not the ticking of clocks, but the long, slow unfolding of matter becoming. Scientists working in the field of materials science have found that even at room temperature, the atoms in glass shift their positions ever so slightly over long periods. They are not fixed in place. They are not truly at rest. Instead, they move like thoughts drifting through a daydream, small, hesitant, almost imperceptible. But together, over decades, these motions accumulate, shaping the material from within. The glass does not forget what it once was. It carries the memory of its heat, its cooling, its composition. And though it holds our gaze with its stillness, it never truly stops changing. In one study, researchers observed ancient volcanic glass, obsidian, that had formed naturally more than 1 million years ago. Using ultrasensitive equipment, they detected molecular rearrangement still occurring inside the material. The changes were slight but undeniable. The glass was not frozen in time. It was simply flowing at the speed of patience. These findings opened new ways of thinking. If even this, the stillest thing we know, is moving, then perhaps nothing is truly still. Perhaps the universe itself is a river, even in its hardest parts. And glass is not alone in its slowness. Many materials exhibit what scientists call glassy dynamics: plastics, polymers, metallic glasses. They too fall into that space between solid and liquid, that long, stretched moment where motion and rest coexist. These materials resist easy classification, much like glass, and yet we use them every day. We hold them in our hands. We build with them. We live within their invisible transformation. This duality, the appearance of stillness and the reality of change, is what makes glass so poetic. It is not pretending, it is not deceiving us. It is simply showing that change does not need to be fast to be real. That becoming does not need to be loud to matter. When we look through an old window pane, we see the world outside, but the glass itself is seeing too, in its own slow, silent way. It is feeling gravity. It is responding to temperature. It is remembering its own making, even as it reshapes itself, molecule by molecule, across time. And just as glass teaches us about time, it teaches us about fragility. Because for all its strength, glass is also brittle. It holds tension invisibly. A chip, a flaw, a sudden force, and it shatters. But this shattering is not weakness. It is a release. The structure, always under quiet pressure, finally lets go. Scientists use this to study fracture mechanics, the way cracks form, spread, and break through materials. Underneath the surface of every smooth pane lies a network of tiny stresses, waiting for the right moment to express themselves. But before that break, there is waiting, there is balance, there is the quiet strength of something holding together longer than it was ever meant to. That is the beauty of glass. It does not rush. It does not demand. It simply endures for as long as it can. And in doing so, it becomes more than a material. It becomes a metaphor, a reminder that resilience is not the absence of pressure. It is the ability to carry that pressure silently over time. In the lab, glass becomes a tool for probing the limits of matter. Scientists create ultrastable glasses by vapor depositing atoms one by one onto a cooled surface, building up films that are more orderly, more resilient than anything made by traditional melting and cooling. These ultrastable glasses resist aging. They hold their shape longer, but even they, given enough time, will begin to move. Nothing is immune to time, not even the best glass. And so we begin to understand the patience of matter, not just as a scientific curiosity, but as a way of seeing the world. We begin to notice that the objects around us, the bottle on the shelf, the window by the bed, the mirror we look into, are not static. They are slow. They are in the middle of their own quiet stories, and those stories are not told in years but in centuries, in the length of shadows moving across a wall, in the way sunlight warms the pane, in the whisper of molecules trading places, without ever making a sound. The patience of glass reflects our own deepest questions. What changes us? What holds us together? How do we carry the pressure of existence without shattering? And if we do break, what does that break reveal? Not weakness, perhaps, but truth. That we were never unchanging. That we were always in motion, even when we stood still. So next time you run your hand across a window, pause, feel the coolness, the smoothness, the weight. Know that you are touching something ancient, something alive in the slowest way possible, and know that it is moving, that it remembers its fire, that it carries time in its silence, just like us. In the heart of every piece of glass, there is a journey unfolding so slowly it escapes our senses. We look through glass and see only transparency, but what we are really seeing is a negotiation, a dance between particles, always shifting, always seeking a more comfortable position. The glass never stops reaching toward equilibrium. It does not race. It does not resist. It simply continues, adjusting its form with a patience that outlives generations. And in this, glass becomes something more than material. It becomes a lesson in quiet transformation. Over centuries, this slow movement leaves subtle signs. Ancient window panes are thicker at the bottom not because of poor craftsmanship, but because of gravity's persistent pull on the restless atoms inside. Stained glass in medieval cathedrals tells the story of more than just devotion and artistry. It tells the story of movement, of change happening at the pace of trust. Scientists have long debated just how much glass flows, but they now agree on one thing. Over long enough spans of time, the structure of glass rearranges. The stillness is an illusion, and that illusion holds a deeper truth, that what we call solid is sometimes just slow. And this slowness is not a flaw, it is a feature, a form of strength that doesn't need to hurry to endure. Unlike metals which corrode or plastics which degrade, glass ages with dignity. It resists the bite of time not by fighting it but by folding into it. It bends inward, absorbing stress, distributing pressure, reshaping itself so gently it seems unchanged. Even when it breaks, it reveals something elegant, a fracture that curves, a shimmer that catches the light. A story interrupted but not erased. This is why glass is so often chosen for things that must both last and reveal. Telescope lenses, museum cases, the domes of observatories, glass protects while letting the world be seen. It stands as both barrier and window, and in this role it carries a quiet authority. It does not need to declare its presence. It simply is, watching, aging, flowing beneath the still surface like thought beneath calm eyes. Even in technology, glass is everywhere. In fiber optics, it carries the internet across oceans, pulsing with light. In smartphones, it serves as our interface with the world, bearing the touch of a billion fingertips each day. And in laboratories, glassware remains the trusted companion of science. Test tubes, flasks, slides, each one crafted to hold truth without contamination. We trust glass because it does not interrupt. It receives. It contains. It holds the experiment, the image, the signal, and in doing so, it holds us too. But what we hold less often is the awareness that glass is moving, that the screen in your hand, the window by your side, the glass of water on your table, none of these are entirely still. They are changing, with the patience of stone and the grace of water. The molecules inside are never fully settled. They are always searching for balance, and that search continues long after we have stopped paying attention. There is something profoundly comforting in this, that even the materials we think of as inert are participating in time, that nothing is truly frozen, that everything, even what seems unmoving, is engaged in the long story of becoming. Glass reminds us that transformation is not always visible. It does not always announce itself. Sometimes it is quiet. Sometimes it takes lifetimes, but it is happening, always. And so we return to the idea that the world is not made of things but of processes, that the wall is not a wall but a slow river, that the mirror is not a mirror but a sheet of light and time woven together, that what we see as finished is still unfolding, and what we call solid is simply slow enough to seem so. Science in its most delicate moments is not about control. It is about witnessing, observing without rushing, trusting that meaning will emerge if we wait long enough, listen carefully enough, respect deeply enough. The study of glass teaches this in every shard, every pane, every ripple of age that warps the view slightly, beautifully. Perhaps this is the ultimate lesson of glass, that stillness is not the absence of movement, but the presence of patience. That to be clear is not to be empty, but to be open. And that to endure is not to resist change, but to let it happen slowly with grace. So the next time you look through a window, think of it not as a frame for the world, but as part of the world's story. Think of the atoms inside, gently shifting. Think of the centuries it might take for them to show their journey. And think, too, of yourself, how you have changed in ways too small to notice, how your memories have flowed, how your edges have softened, how your center has shifted without breaking. Like glass, you are moving. Like glass, you are still becoming. And like glass, you are holding more than anyone can see. Before the heart beats, it listens. Deep within the chest, wrapped in chambers and muscle, lies a current, not loud like thunder, not bright like lightning, but steady, silent, and sure. It sparks in the dark, without announcement, just beneath awareness. This is not the heart you feel thudding after a climb, not the one drawn on greeting cards or carved into trees. This is the true heart, the electrical engine that begins before we are born and hums without rest until our last breath. It beats not because of blood, but because of charge. Because within every cell lies a whisper of voltage, and the body knows how to listen. The signal starts small. In a patch of specialized cells called the sinoatrial node, nestled in the upper right corner of the heart, an impulse flickers into being. It is not created by nerves or by thought. It arises from within, from ion channels opening and closing like tiny doors, letting sodium rush in, letting potassium flow out. This dance of charged particles creates a rhythm, a pulse, a self-sustaining spark that travels through tissue like a gentle tide. With every flicker, the heart contracts, not randomly, but with a purpose written in the language of electricity. And what a language it is! As the signal flows from the sinoatrial node down to the atrioventricular node, it pauses, just for a moment. A breath held between chambers. This delay is not a flaw, it is precision. It allows the atria to contract first to fill the ventricles. Then the wave continues, sweeping through fibers that lace the heart like threads of silver, pulling the ventricles into motion. One impulse, one pause, one coordinated push, over and over, without thought, without interruption. To understand this is to understand that the heart is not just a pump. It is a conductor, a lighthouse of charge, and every cell in the body relies on its rhythm. The brain listens, the muscles follow, the lungs respond, all because of those tiny shifts in voltage, so faint they barely measure on the skin, and yet strong enough to drive life. Electrocardiograms trace these waves in ink, drawing peaks and valleys that echo across the page. But the real rhythm lies deeper, in the calcium flowing like memory inside heart cells, in the sodium sparking against cell walls like fireflies in fog. And yet we rarely feel it. The heart's electricity does not announce itself. It does not demand attention. It hums beneath our senses, faithful and unseen. And in this way it becomes a model for all quiet systems, the ones that carry life not with sound but with steadiness. The ones that remind us that silence is not absence, it is structure, it is design, it is everything moving the way it should. Now imagine a world without it. A heart without charge is a body waiting in stillness. CPR, defibrillators, pacemakers, these are our tools to reawaken the current, to invite the spark back into the cells. But even these are imitations of something simpler, something older, because the heart does not begin with an external jolt. It begins within, long before lungs fill, long before eyes open. The embryo's first motion is not a breath or a stretch, it is a beat. A pulse born from nowhere, rising from inside the cells like a memory from before time. And that beat continues, through fear and sleep, through illness and growth, through grief and joy. It adjusts, it speeds, it slows, but it never forgets its source. Each beat is the echo of that first flicker, each rhythm a reply to that first whisper of charge. You are alive because your cells remember how to listen. And still, this electricity is not just mechanical. It responds to thought, to feeling. A moment of terror sends adrenaline rushing, quickening the pace. A moment of calm slows the wave. The heart listens to the brain but also speaks back, through pressure, through rhythm, through the speed of the beat. This is not metaphor, it is biology. The body is a conversation, and the heart's quiet electricity is one of its clearest voices. So next time you place your hand on your chest and feel that subtle thump, remember, you are not just feeling blood, you are feeling light, motion born from charge. The silent storm beneath your skin that carries you forward, one quiet flicker at a time. Within the tiny universe of the heart, voltage travels not like a river but like breath. In and out, rise and fall. Each beat is a soft exhale of charge. And though it may seem mechanical, ions moving in predetermined patterns, channels opening and closing on cue, there is nothing cold about it. Because within this rhythm lies the warmth of life itself. The sinoatrial node may be only a few millimeters wide, but it is the origin of every heartbeat you've ever had. And it never rests. Not even in sleep, not even in sorrow. It sends its message again and again, a Morse code made of muscle, repeating the same soft syllable, live. As the electrical wave moves through the heart, it moves through history too. This system has not changed much over millions of years. The same structures found in birds, in whales, and elephants exist in us. Different sizes, different tempos, but the same design, the same promise that something deep inside will keep the beat, even when the rest of the world stumbles, even when the sky goes quiet. The heart does not need to know the reasons. It only needs to remember the pattern, to obey the quiet rules written in its cells. Scientists have studied this system for centuries. They've traced the paths of conduction with fine instruments, recorded the spike of action potentials, mapped the flow of sodium and potassium ions across the cardiac membrane. But beneath all the graphs and models lies something harder to describe: the way the heart holds on, the way it reestablishes its rhythm after a pause, the way it entrains itself to life, adjusting its frequency to the needs of the moment. It is not just a pump, it is a musician. A keeper of time that plays in silence, without audience, without applause. And when something disrupts that rhythm, when arrhythmias form, when the beat skips or stalls, it is not because the heart has forgotten, but because something is interfering with its memory. A scar, a blockage, a chemical imbalance. The signals become tangled, the impulses arrive out of order, the body notices. You feel it in your throat, in your chest, in your breath. A missed beat, a sudden race, a pause that seems too long. But often the heart finds its way back. It returns to the pattern, to the steady repetition that has always carried it forward. This resilience is part of what makes the heart extraordinary. It is not invincible, but it is persistent. In moments of trauma, when blood pressure drops, when consciousness fades, the electrical system continues to fire, trying again and again to restart the rhythm. Defibrillators do not give the heart life, they remind it. They shout when the whisper has gone silent, but the spark itself must still be there, waiting, ready to begin again. And sometimes we assist that spark with machines, pacemakers, devices implanted under the skin, sending regular electrical impulses when the natural system grows tired. These devices are not replacements for the heart's wisdom. They are reminders, gentle nudges that help the rhythm stay true. Even in this, the body and technology become collaborators, working together to keep time. But there are still mysteries, still places where the science fades into silence. Some people's hearts beat more slowly yet perfectly. Some beat rapidly yet safely. Emotion alters rhythm in ways we cannot always predict. The mere act of holding someone's hand can change the pace of their heart. A moment of grief can make it falter. A moment of love can steady it. And though we know the chemistry, adrenaline, cortisol, oxytocin, we do not fully understand how feeling becomes frequency, how memory becomes muscle, how thought becomes thump. And perhaps that is the beauty of it, that something so regular, so measurable can still remain mysterious, that beneath the electrodes and monitors there is still a wonder we cannot map. The heart, after all, is not just an organ, it is an experience, a presence. It is the first part of us to move and often the last to rest. It marks the beginning and end of a life not with words but with rhythm. And in between it records everything. The heart keeps no diary, but it remembers all the same. It remembers the adrenaline rush before a fall, the slow beat of sleep, the quick flutter of laughter, the echo of music heard in the dark, the silence of waiting. It stores no names, no faces, but it remembers feelings, and it reflects them back in the way it moves. In that movement lies a kind of truth, that life is not sustained by strength alone, but by rhythm, that what keeps us going is not force but flow, the quiet, continuous passage of charge from cell to cell, the agreement of tissues to move together, the decision, made 1,000 times a minute, to keep beating, keep breathing, keep becoming. And that decision is made in silence, not with permission, not with discussion, just a flicker, just a flow, just a heartbeat that begins within and ends nowhere because it never really ends. It only continues, one wave after another, in a song older than speech, deeper than thought. So tonight, when the world is still, place your hand over your chest and listen, not for the noise but for the rhythm, for the signal, for the whisper of the sinoatrial node still speaking, still guiding, still believing that the next beat will come. And it will. Even now, as you read this, your heart continues its ancient task, quietly, unfailingly. It does not ask you to notice. It does not wait for your gratitude. It simply carries on, one contraction at a time, moving blood and memory and breath through every corner of you. It is so reliable that we forget it. We go hours, days, years without thinking of the work it does, but it never forgets us. It works when we are laughing, when we are crying, when we are asleep. It works through every argument, every moment of stillness, every uncertain pause. And it does so with a rhythm born before language, tuned to the silent order of cells. Scientists call this intrinsic rhythm automaticity. It means the heart generates its own signal without needing external commands, a muscle that sparks itself, a loop that begins nowhere but sustains itself everywhere. In the beginning, this seems mechanical, as if the heart were a wind-up toy, but it is more than that. It is trust, cellular trust, tissue shaped by time to act without needing to be told, a system so well designed that it learns to lead itself. And what makes this even more profound is how that leadership adapts. The heart does not keep one beat, it keeps many. It speeds up when we run, it slows down when we rest, it races with panic, it calms with breath. It listens to our nervous system, to our hormones, to our thoughts. It synchronizes with breath in ways we do not choose. It modulates itself based on posture, temperature, and even light. This flexibility, this responsiveness, is not an afterthought. It is part of the heart's intelligence, a wisdom of flesh and voltage that responds with grace to the changing moment. Even when the rhythm falters, the system tries to find its way back. There are backup nodes, secondary pacemakers, alternative routes. The atrioventricular node can take over. The Purkinje fibers can improvise. The body has layered in redundancy just in case, because the rhythm must continue, because the song cannot end too early. This built-in resilience is not a sign of fear, it is a sign of reverence. Reverence for the rhythm that defines life. In hospitals, monitors trace the lines of our heart's signal. A spike, a dip, a wave, repeated every second. Doctors read these patterns like language. They see arrhythmias, delays, blockages, but they also see stories. They see a heart laboring through exhaustion, a heart responding to medicine, a heart that has endured, and sometimes they see something so rare, so perfect that they pause. A rhythm so steady it feels like music, not manufactured but earned. There are moments in meditation, in deep rest, when the heart slows to a perfect cadence, each beat like a bell. In those moments, something remarkable happens. The brain waves and the heart rhythm sync. The nervous system enters balance. The body rests in its own current. And though we rarely notice, these are the moments that restore us. When the rhythm is not just background, it becomes the foundation. Throughout your life, your heart will beat over 2 billion times. Each beat generated not by thought but by trust. Trust in the electrical whisper. Trust in the molecular wave. Trust in the design that was shaped over billions of years, passed down through fish and reptiles and birds and mammals, until it became the rhythm in you. And that rhythm, fragile yet persistent, binds you to all living things. Even in death, the final note is marked not by silence but by the fading of that rhythm. The last beat, the last wave, the final signal. And yet even then it is not erased. It leaves behind traces, not just on machines but in memory, in the people who listened, in the spaces that felt its presence. The echo of a heartbeat lasts longer than we imagine. And perhaps that's the greatest gift the heart gives us, not just life but continuity. A sense of time that does not measure days but beats, that does not record events but pulses. In that continuity there is comfort. We are carried, we are accompanied, we are never truly alone, because as long as the heart beats there is a rhythm that holds us, a pattern that believes in us, a song that never asks for words. So when you lie awake in the dark, listening to the quiet, remember, your heart is still speaking, still marking time, still sending light through every part of you. You may feel lost, but the heart knows where it is. It beats not because it must, but because it can, because it was made to, because you are still here. And that is reason enough to keep going. The next beat is already on its way. Inside every living cell, in every leaf and lung and fingertip, there is a conversation happening, silent, invisible, constant. It doesn't speak in words and it doesn't wait for approval. It moves beneath thought, beneath breath, beneath awareness itself. This is the language of enzymes. Not a language of sound, but of shape. Not of letters, but of locks and keys. It is a quiet code, older than speech, written into the folding of proteins and the trembling of molecules. And every second, this code is what keeps us alive. Enzymes are not creatures, but they behave like they are. Each one is a protein, twisted into a shape so precise that it can recognize only one specific molecule, its substrate. When they meet, something extraordinary happens. A reaction that might have taken years in open air now happens in the blink of a heartbeat. A bond breaks, a bond forms, a transformation occurs, all because two shapes found each other, all because the enzyme whispered, now. They do not burn or explode. They do not shout. They work quietly at room temperature in the soft light of cytoplasm or the cold dark of mitochondria. They speed up life's chemistry not with heat but with precision. And they do it over and over, millions of times a second, without tiring. One enzyme might process 1,000 molecules in a minute. Another might manage just a few but with more care. Some take sugar and break it apart. Others knit DNA like lace. Some unwind knots in proteins. Others carry signals between cells. Together, they form the hidden engine of all biology. To watch an enzyme at work, even through the lens of the most advanced microscope, is to see patience made real. A molecule drifts, an enzyme turns, they meet, they fit. The reaction occurs and then they part. No sparks, no fire, just quiet cooperation. And the enzyme waits for the next one, already ready, already folded, already shaped to help. And their shapes are everything. One change in one amino acid and an enzyme may lose its ability to function. That's why evolution guards them so carefully. Why cells spend energy to fold them just right, to tuck every loop and coil into its perfect place. A misfolded enzyme can mean disease. A missing one can mean death. But a well-made one, it can perform miracles. It can allow life to thrive in boiling vents or frozen ice. It can repair DNA in real time. It can turn sunlight into sugar. It can digest the food you eat, breathe the oxygen you take in, and build the thoughts you're having even now. And you've never felt them, never heard them, never seen them with your eyes. They are smaller than viruses, smaller than light's ability to reflect. But they are there by the trillions in every cell of your body. And they are talking, not in noise but in chemistry, not in voice but in transformation. Each one fluent in a single phrase, each one saying, this now. And they don't work alone. Some hand off products to others, forming pathways that loop and spiral and feed back into themselves. These are metabolic pathways, and they are as intricate as cities, full of roads and signals, detours and checkpoints. A product becomes a new substrate. A chain begins, each step handled by an enzyme who knows exactly what to do and when to do it. They don't compete. They don't debate. They simply do what they are shaped to do. Even emotions, even memory rely on them. To form a memory, neurotransmitters must be released, and those neurotransmitters are built and broken down by enzymes. To feel hunger or calm or joy, hormones must be made, and again, enzymes guide that making. They are the craftsmen of the cell, the unsung builders, the quiet adjusters. They don't demand attention, but without them, nothing would work. And what's even more astonishing is how they're made. Your cells read DNA and translate its code into strings of amino acids, but those strings are not yet enzymes. They must fold. They must be guided. They must find their final form in the watery world of the cell. Some fold on their own. Others need help. Molecular chaperones, also made of proteins, assist in this process, gently preventing mistakes, gently shaping the folds. It is like origami made of atoms, and the result is a tool with purpose. In this folding is encoded function. The shape of the active site, the groove or pocket where the chemistry happens, is as specific as a puzzle piece. If the substrate doesn't fit, the enzyme does nothing. If it does, everything changes. This is what scientists call specificity. It's why enzymes can be used in medicine, in industry, in research, because they know exactly what to touch and what to ignore. And sometimes we harness them. We isolate them, purify them, use them to clean wounds, to synthesize drugs, to alter crops. We add them to detergents. We use them in labs to copy DNA, to edit genes, to build new life from scratch. They allow us to do more, not with force but with elegance, with the power of shape and time and silent, repeating transformation. So the next time you take a breath, remember, enzymes help pull oxygen into your blood. The next time you eat, remember, enzymes are breaking down the bite molecule by molecule. The next time you heal, remember, enzymes are rebuilding what was torn. You do not need to command them. You only need to be alive. And they will keep working in the dark, in the quiet, in the endless, humming rhythm of the cell. They are the hidden verbs of life, the silent action, the unspoken fluency that allows matter to become motion, that allows chemistry to become you. Enzymes do not work in isolation. Like instruments in a silent orchestra, they depend on harmony, on timing, on balance. Inside each cell, thousands of different enzymes perform their unique roles, but together they create a smooth, flowing symphony of life. One enzyme breaks down a sugar molecule, handing off its pieces to another that reshapes them into something useful. Another waits nearby to add oxygen or remove a hydrogen atom. There's no shouting, no confusion. Just a quiet assembly line of transformation. This is how metabolism happens, not in great leaps but in careful steps. Each step matters. If one enzyme is missing or slow, the whole process can falter. That's why cells regulate them so carefully, turning enzyme production up or down depending on the time of day, the temperature, or the body's needs. At dawn, enzymes that help digest breakfast become active. At night, others take over to help the body repair and rest. The dance of enzymes never stops, but it changes its rhythm to match the moment. And still, we barely notice. The digestion of your last meal involved over 20 different enzymes, each perfectly timed, each breaking, building, shaping molecules into energy, into growth. Even your DNA is maintained by enzymes that clip errors, repair damage, and rewind the strands like gentle hands on a spool. Without them, the code would fray. The body would forget itself. But with them, it remembers.